All right, we've got 25 over 36 multiplied to 24 over 15. Now, traditionally, when you multiply fractions, we simply do, listening, top with top, bottom with bottom. Okay, so we normally do top with top, so 25 times 24 and 36 times 15. But that's really large. That takes a lot of effort to do, and it's not required that that's what you want to do. What we want to do is we want to simplify this to make it easier for ourselves. So back in chapter 3, when you were doing fractions, we learnt equivalent fractions. Now, one of the things we know about multiplication of fractions is that when you multiply digits, they don't have to be in that particular order. You can actually swap them. Okay? Thank you. You can actually swap the values. So, one of the techniques I showed you is that 25, you look for a common factor with either 36 or 25 in the denominator. That's what you're trying to pick. And the reason why you can do that is because 15, 36 can be swapped. And you got 25 over 15 or 25 over 36. Now, out of those two, which one has a common factor? 25 and 36 or 25 and 15? 25 and 15, very good. But what's the highest common factor? What's a factor that fits in both? 5. So we know that 5 can go into 15, but 5 can also go into 25. Now back in chapter 3, I would have got you to do this. I would have told you I wanted you to rewrite that as 25 over 15 times 24 over 36, because I wanted you to understand the mathematics. At this point, we're going to move forward, and I'm not going to require you to do this step. Okay, listening? Thank you. I'm not going to require you to do that step there, but I hope that you still remember and understand that the reason why this works, or this technique I'm going to show you works, is simply because multiplication 36 times 15 or 15 times 36 is the same answer. But when you swap them, this fraction, 25 and 15, can be simplified. And like you said, the highest common factor between them was that they both have a 5. That's where it's coming from. So, instead of rewriting it the way I have over here, normally at school, in high school, the way we teach it, we normally just say, well, 5 goes into 5 3 times, and 5 goes into 25 5 times. That's how we normally teach it. It makes it nice and easy and quicker, but thank you, actively listening or actively note-taking, right? The Rubik's Cube, I haven't asked you guys to, I haven't confiscated it from you, but I have asked you to put away. Okay? Now, you got 5 over 3. This is the reason why this works is because you're essentially simplifying 25 over 15, and that becomes 5 over 3 multiplied 2. Notice you now have 24 over 36. So, what's a better way of doing this? Well, 25 over 36 times 24 over 15, you can see that 5 goes into 25 5 times, 5 goes into 15 3 times, but you can also see that 24 over 36, 24 over 36 is a common factor. 6. Very good. How many 6s in 24?
4. No. 5. No.
It's everything?
4.
4. Very good. 6 goes into 24 4 times. How many 6 goes into 36? 6. Very good. Boys, that's my third time asking. Okay, so I've already said about the Rubik's Cube, and now I'm asking, politely as well, by the way, I'm asking that if you're not actively listening, then you're actively note-taking. But you're not going to be disrespecting me and talk while I'm speaking. That's a third time. Disrespectful. See, when you speak, I'm listening to you. But you don't do that when someone else is speaking. That's being recorded too. Cooper, who else do we have? So you guys, when you watch this again, you're going to remember. Did you point at Michael? Thank you. We had Jack, Ryder, Blaze. I expect the best of you guys.
It was Michael.
You can probably tap on them too. You can tap on them and just say, okay? Alright. Alright. Are we back? We good? Jake. Obviously they're distracted too. Thank you. Thank you.
Oh, I'm so distracted.
I know.
I'm so distracted.
Thank you. Get it? I know it's generally harder, but the reason why I'm emphasizing this is because you guys didn't do well on division. Otherwise, I normally am okay with ignoring it. Yeah? It works really well. I'm quite tolerant. But I'm not okay when you're weak on something and then you're not listening and then you struggle on it again. One, it upsets me because I know I can help you. The two, I feel like you're disrespecting me and you're not trying your best to be the best version of yourself. Okay, so that's why I'm trying to be as patient as I can, because I want to make sure that you do know how to do division. Okay, because right now I'm just doing division of numbers. When I get to this side, I expect that if I give you more challenging questions, you should be able to do them. Okay? Here we go. Let's try again. So we're back to 25 over 36 times 24 over 15. What I'm trying to say to you is you're looking for common factors with top and bottom. Never top and top, and never bottom with bottom. Okay, because it doesn't work that way. You can't do 15 times the 20 and then say, oh, yep, I can cross off the 15 and 20. That shows to me that you don't understand division is based on equivalent fractions, meaning it has to be a top number and a bottom number, not bottom and not top and top. Okay? Now, using this understanding, once you've simplified it, it's much easier now to multiply 5 on 6 times 4 on 3 compared to 25 times 24 and 36 over 15. So your answer should then be 20 over 18. But notice this is not your simplified version. Why? Correct. The 4 and the 6, there's still a common factor of 2. Until you simplify every single fraction, then you get your simplest form. Okay, this is one of the reasons why simplifying fractions, multiplying, dividing was tricky. It's because your fractions or your times tables had to be strong. If your times tables are lacking, then it's hard to find the highest common factor. Okay, so the answer for this one should be 2 and 3 on the bottom, so therefore your best answer is 10 out of 9 is what you should be getting. Okay, so same thing with fractions. With algebra, you will be working in that format. The only difference between them now is you've got an extra letter. Now let's do a quick recap here. What is A divided by A equal to again?
A squared.
Be careful. So this is what I mean. I just want to make sure that you know how to divide. See, division is always the one that gets students. It's 1. See, I want you to think A is just a number. Don't think of it as a letter, but think of it as a number. If you replaced it as 3, what's 3 divided by 3? How many 3's? 1. You see, that one was easy, but why is it that students always get A divided by A wrong? It's because you're not thinking of it as a number, you're thinking of it as a letter. Okay, so A divided by A, please write that down, equals 1. To remind yourself, it cancels out to be 1. Yes, Michael?
With that question before, I got still 6 and 2/3. I don't know what that is.
You got 26 and 2/3.
No, I got 6 and 2/3.
6 and 2/3.
Because I did, I simplified them both, and I got 5 over 3 is 4 over 6.
Yeah.
And then to get a common denominator.
No, you only do common denominator if you're adding. Yeah, plus or minus requires the same type of fraction, not multiplication. Yeah. All right, let's do this example over here. All right, in your exercise books, can I please have you copy these 2 examples? Please copy these 2 examples down. Please copy these 2 examples down. And then I'm going to give you a trickier one. After this one, I'm going to give you a trickier one. But let's see. So we do 2a over 5 times 3b over 7. Here we go. Your job is to look at the numerator and denominator. Is there a common factor between, say, 2 and the two numbers on the bottom there? You got 5 and 7. Is there a common factor there?
No.
No. 2 with 5, 2 and 7, there's no common factors, so can't do anything with the 2. Then you look at the 3 and you say, is there a common factor of the 3 and the 5 and 7?
No.
No. So you can't do anything with the 3. Then you'd still do the same thing with the A.
No.
There's no A's anywhere else because the only thing we can simplify is if there's another A. We don't have any other A's in the denominator. So A doesn't do anything. And then B?
No.
Nothing.
No.
So that means you can't simplify this fraction, and then that means you have to multiply like the way you normally do with fractions, which is top with top, bottom with bottom. So in your next line, this is what I want you to write down. You would then have 2a multiplied to 3b all over.
5 times 7.
Very good. So write that down. Thank you.
6ab.
6ab.
5.
Very good, James. You're very fluent with this. Very good. Now, we're going to follow the same pattern for part B. Part B, let's do it again. Same thing. Let's have a look at the 4. Is there a common factor?
Yes.
Which one?
2.
There's a common factor 2. Can we see that 4 and 2 have a common factor? And this is where we're going to do. 2 goes into 2 once, and 2 goes into 4 how many times? 2. So let's write our fraction again, but before you do so, check. Any other common factors? We've got a 3 over here.
Yes.
3 and 15. What's a common factor?
1 and 5.
Good, because 3 goes into 15 5 times,
5.
and 3 goes into 3 once. You see what I'm doing there? So, your next line, you can actually write it as 2x over 5 times 1y over 1.
You just write y, you don't need a 1.
You can. I'm just writing it so that you can see where this 1 came from. But very good. So, once you write it like this, the hardest part is not here. The hardest part was to see what I did here. And that's where the difference between your factors and multiplications are. If you're strong with them, this should be okay. All right. Now, moving on to the next line.
2x y over 5.
You would do 2x times y.
Very good. 2x times the y, 5 times the 1.
Is 2xy over 5.
Very good. Okay, so you guys are definitely showing, at least on this side here where James is sitting, I'm getting a sense that they understand this fraction. Now, I'm going to move on to an example I'm going to make up.
Especially Jay.
And I want you to have a go with this example. Okay, so I'm going to make an example and I want to see if you can use what you've understood so far to take it up a notch. Okay, so I'm going to go up a notch. Here we go. C. Copy C down. I'm going to make it up. So it's going to be relatively harder. All right, year 8s. I would like you to copy this one. Now, this one's going to be tricky, but if you can do it, it means you're understanding what I'm trying to teach you. Here we go.
15 and...
So you're combining everything you've learnt with algebra, with fractions, with simplifying. Have a go with this one.
8 and 6 matches.
Eight and 6.
8 and 6, yeah.
Have a go with this question.
Do you write that down?
Yes, please. This is a harder one. You won't find that in your textbook.
How do I get to do that?
16, please. Can you use something you simplified to simplify something else?
Yeah.
Okay.
All right. As you're having to think about this, let's do it together. Here we go. Same drill. Normally, when you're simplifying fractions and you're multiplying, what you would do, top with top, bottom with bottom. But before you do so, I want you to simplify where you can. Okay, so you need to simplify this whenever possible. It makes it easier for you. So the first thing I'd ask you to do is then to look, okay, you've got a 15. Is there a common factor in the denominator with 15 at the moment? Is there a common factor of 15 and the number's there?
No.
Yes, there is.
Oh, there is.
Yeah. 15, not with the y, because 15 and y aren't common factors, but 15 and 6, they both have a common factor. 3. So you can simplify that. So simplify where you can first. You can do the 8 and 6, but you can also do 15 and 6. Doesn't matter which one. The point is to simplify them. Now we know that 3 goes into 6 2 times. 3 goes into 15 5 times. So what I've done here is I've simplified my next line into 5x cubed y squared over 2, because I'm dividing the common factor of 3, multiplied to 8 x over y to the power of 4. Okay? Now, again, you can always multiply top and top, bottom and bottom, but the more you simplify early, the easier the problem becomes.
8 and 2.
8 and 2. So once I've done the 15, I'm now going over to the 8, and I ask the same question. And we know 8 and 2.
4 and 1.
Very good, but what's the highest common factor of 8 and 2? 2. So here we go. How many 2's and 2's, and how many 2's and 8's? Very good. 1 and 4. This now gives us a new line, which is 5x cubed y squared over 1 times 4x over y to the power 4. Now, this is where, listening, this is where what you did with division of fractions and division of algebra is where it becomes important. So, we've done the numbers. 5 and the 4 is as simplified as possible. But, let's look at the letters. Which letter has a common factor that you can see top and bottom at the moment? Which letter? Y. We've got both of them have Y's here. Now this is what I want you to think about. What is y squared divided by y4? Because that's what we're doing here. We're saying y squared divided by y4.
Y times y over y times y times y.
Very good. So I like the fact that James is breaking this apart. Okay, so if he breaks it apart, you can see what the answer should be. Y to the power 4 means y times y times y times y. But here we go.
2 y's in this way.
Correct. Now these two y's, when we divide them again, what's y divided by y? 1. So this cancels out to be 1. What's y divided by y again?
1.
1. So the numerator, 1 times 1, should give you a 1 on the top, but on the bottom, y times y left over should be y2. Y2. Now, this thing, I want you to see this part here. So in high school, thank you. In high school, that y squared divided by y4, a lot of my teachers back in the past would have just said, if you got 2 on the top, they would have said, cancel it out, take away the 2 on the bottom as well, then you end up with 2 left over. So they would just do it that way. So it's fair call, I get it. The problem I don't want you guys to get into is, because this is a common mistake that keeps going all the way to senior level, is that if you get used to crossing things off like that, without understanding why this actually works, when I give students things like this, students do the same thing. They will cross these two and say, that's a 2 there. And then they let that go, and it's wrong. Okay? You're eight. Disrespectful. Not right now. Third time as well. What I'm trying to mention here is something that I'm trying to make sure that you're avoiding that same mistake. The key thing is I can teach you the shortcut, but the shortcut leads to this problem. I want you to avoid this. That's what I'm trying. I'm trying to make sure that you know you can't do this. If I'm teaching you this particular way, that's what I'm worried about. That's why I prefer that you take what James was saying before, expand it out, and then you can see why you can cancel them out. Why can you cancel them out? When you're multiplying, it's okay to divide y divided by y was 1, y divided by y, which is 1. That's why it feels like the 2's cancel out here, and you're left with 2 left over. The reason why it doesn't work here, can anyone see why you can't do it here? Why can't I do the same thing if you've got a y4 and you've got a y squared here? Why can't I do this? Why doesn't that work there?
Because that's not the same.
It's not the same, but what's the key thing that makes it different? Yeah? The plus sign, thank you. I want you to have a look. This here is very common when you get to senior levels. The difference here is they're all multiplication. Do you notice? Everything we're doing is multiplication. If you ever get a plus in a multiplication or fraction problem, don't assume that you can just cross things off. You can cross them off when they're all timesing. It's okay, because it doesn't matter about the order, it's division, it's okay. But when you mix addition and multiplication in a fraction, you should be careful. And that's the difference, understanding the operations of addition and the operations of multiplication. They're different. Okay, so that's what I want to make sure that you understand. So if you understood how to simplify this problem, that's very good. That's already challenging. It's not part of your course, but technically you should be able to do it. This is a year 9.